Far below the ground we walk on, sealed inside stone that formed over 65 million years ago, researchers have uncovered something deeply unsettling. Tiny spherical particles made of rare metals spread across the planet in a pattern that looks disturbingly familiar. It matches, almost perfectly, the fallout signature left behind by modern nuclear detonations. But these particles existed long before humanity ever appeared. Long before cities. Long before tools. We've always assumed we were the beginning. The first species to split the atom. The first to reshape metals at extreme temperatures. The first to burn ancient fuels and permanently alter Earth's atmosphere. But what if that belief is wrong? What if our planet hosted advanced societies long before us? Societies erased not by war or collapse, but by time itself. Geological time that grinds mountains to dust and rewrites history layer by layer. Today, we explore evidence that challenges our understanding of Earth's past. Traces of vanished technology, unexplained extinction events, and enormous gaps in the fossil record that refuse to be ignored. Prepare yourself. We begin. Music. In 1980, geologist Walter Alvarez was studying rock formations in Italy when he encountered something remarkable. A razor-thin layer of clay separating two geological eras contained iridium concentrations 30 times higher than normal. Iridium is extremely rare on Earth's surface, yet common in asteroids. That discovery reshaped science. It confirmed that a massive space impact ended the age of dinosaurs 65 million years ago. One single event left a chemical scar so distinct that it remained visible after tens of millions of years. And that raised a dangerous question. If a single day-long catastrophe can leave such a clear signature, what would thousands of years of industrial activity leave behind? And more importantly, would we even recognize it? This question gave rise to what is known as the Silurian Hypothesis. Named after a fictional ancient civilization, the idea isn't science fiction. It asks whether technologically advanced societies could have existed deep in Earth's past, leaving behind traces that have been altered, buried, or misread as natural processes. Consider time on a planetary scale. If a civilization like ours lasted 10,000 years, it would occupy a fraction of Earth's 4.5 billion year history. Detecting it would be like searching for a single torn page in a library of millions of books. Yet such a civilization could not exist quietly. Any advanced society must consume energy, modify its environment, and generate waste. Those effects don't vanish when buildings fall. They become locked into ice, sediment, and stone. We understand our own footprint because we are actively creating it. We flood the atmosphere with carbon dioxide. We distribute plastic particles across the globe. We generate radioactive elements that will remain detectable for thousands of years. To future scientists, our presence will be impossible to miss. But earlier civilizations may not have used our technologies. They may have relied on unfamiliar energy sources or materials that degrade differently. Their industrial fingerprints might already be known to us, just misunderstood. The iridium boundary proves Earth is an excellent historian. If it can preserve the memory of an asteroid strike, it could also preserve evidence of ancient societies that thrived for thousands of years. When scientists began re-examining geological data with this possibility in mind, what they found was unsettling. The fossil record, which should tell the full story of life, reads like a book with most of its chapters missing. Vast stretches of time appear empty, interrupted by sudden bursts of complexity. The Cambrian explosion, around 540 million years ago, is the most famous example. Complex life forms appear abruptly, eyes, shells, limbs, without clear ancestors. Evolution should be gradual. Instead, the record shows a leap. And this isn't an isolated case. Again and again, life seems to reset. Species emerge suddenly, dominate briefly, then disappear. New forms arrive fully developed, with no obvious lineage. Some gaps can be explained. Soft organisms don't fossilize well. Conditions for preservation vary. But not all absences are random. Many align with sharp shifts in atmospheric chemistry, ocean composition, and global climate. Take the Great Oxygenation Event 2 billion years ago. Oxygen levels surge, wiping out most existing life while enabling entirely new ecosystems. Officially, this is attributed to photosynthetic bacteria, but the speed and precision of the change are unusual. The pattern resembles what might occur if atmospheric chemistry were deliberately altered on a massive scale. Throughout Earth's history, we see long periods of stability interrupted by rapid planetary transformations, mass extinctions followed by sudden diversification, chemical anomalies embedded in stone, planet-wide system changes that appear coordinated. These could be natural processes we don't yet understand. Earth is complex. Feedback loops can trigger abrupt shifts. Or they could be something else. What if some extinction events marked the collapse of ancient technological civilizations? Their activities could have destabilized ecosystems, erasing species, and leaving gaps we misinterpret as evolutionary mysteries. The rocks themselves may hold the clearest clues. Industrial activity leaves chemical signatures long after physical structures decay. Isotope ratios, metal residues, and synthetic compounds become permanent entries in the geological archive. Modern industry produces unmistakable markers. Fossil fuel combustion releases carbon with a distinct isotopic fingerprint. Nuclear testing creates elements that do not exist naturally. These signals will outlive us by millennia. Yet similar anomalies appear in strata formed long before humans existed. At the Permian-Triassic boundary, Earth's most devastating extinction, carbon isotope patterns mirror those produced by massive fossil fuel burning. The scale suggests a release equivalent to exhausting all known reserves in a short geological window. Volcanism is often blamed. Methane release is another explanation, but neither fully accounts for the precision of the signal. Ice cores spanning hundreds of thousands of years show repeated episodes of rapid atmospheric change. Greenhouse gases spike abruptly, linger, then fade. The pattern repeats, always preceded by subtle chemical shift that suggests deliberate manipulation. Rock layers in Colorado contain microscopic metal spheres, titanium and rare alloys, identical to byproducts of high-temperature industrial processes. Yet these layers formed long before metallurgy existed, at least according to accepted history. Deep-sea sediments show similar anomalies. Metals disperse globally, as if carried through the atmosphere from countless sources operating at once. And then there are the materials that should never be there at all. Plastic is humanity's most durable artifact. Long after our cities vanish, microplastics will remain trapped in sediments, marking the beginning of a new geological age. Plastic resists decay. In deep oceans or frozen environments, it could survive for millions of years. That makes it an ideal marker of industrial civilization. But here's the problem. Sediment cores from remote ocean basins contain microscopic particles resembling synthetic polymers in layers millions of years old. These particles share the same resistance to degradation in chemical structures as modern plastics, yet predate humanity by an impossible margin. They appear in distinct layers, separated by vast stretches of time, suggesting repeated cycles of production followed by complete disappearance. Their global distribution implies planet-wide use. Even more disturbing, some of these ancient polymers show molecular designs more advanced than our own. If that is true, then the question is no longer whether civilizations existed before us, but how many times history has already been erased. Their structure reveals intentional design, engineered to last, to resist heat, pressure, and chemical decay. These materials weren't accidental. They reflect a deep mastery of material science far beyond primitive experimentation. Drilling deep beneath Antarctica's ice sheet has uncovered frozen layers containing the same synthetic particles, sealed inside ice that formed hundreds of thousands of years ago. The particles remain perfectly intact, their molecular arrangements unchanged, preserved like time capsules. There is no ambiguity about their origin. They were manufactured. These findings force an uncomfortable choice. Either natural processes can somehow replicate advanced polymers under unknown conditions, or intelligent societies master complex chemistry long before humanity ever appeared. If these materials truly represent ancient industry, then civilization did not rise once, it rose repeatedly. Each time, it flourished, altered the planet, and then vanished, leaving only microscopic echoes behind. In Australia, certain rock layers were long classified as unusual mineral formations, but closer inspection revealed something else entirely. The minerals were degraded remnants of synthetic compounds, built from intricate molecular architectures that require precise manufacturing. Organic material embedded nearby dates these layers to millions of years ago. Yet the synthetic fragments show almost no aging. They lack the breakdown expected over such immense spans of time. This level of preservation suggests either physics we do not yet understand, or production techniques that surpass modern human capabilities. The implication is unsettling. We may be walking across the remains of earlier civilizations without realizing it. Their greatest technological achievements reduced to dust-sized particles, misclassified as geological quirks simply because we assume we were the first. But the most alarming clues lie far below the surface, where nuclear signatures tell a story that should not exist. In 1972, scientists studying uranium ore in Gabon's Oklo mine made a discovery that rewrote nuclear physics. The uranium showed evidence of sustained chain reactions that occurred naturally 2 billion years ago. These ancient reactors ran for hundreds of thousands of years, producing radioactive byproducts once thought possible only through advanced technology. Oklo proved something crucial. Nuclear activity leaves fingerprints that never fade. Isotope ratios produced by nuclear reactions are unmistakable and remain detectable for billions of years. That realization prompted scientists to search for other nuclear anomalies. What they uncovered carries staggering implications for the Silurian Hypothesis. Uranium deposits in Kazakhstan contain isotope patterns identical to those created by nuclear weapons testing. These ratios appear in rock layers formed 50 million years ago, long before any known intelligent species developed atomic science. Unlike Oklo, these signatures are too precise and too concentrated to be natural. Similar nuclear markers have now been identified on 6 continents. Their global distribution suggests coordinated activity on a planetary scale. Yet the rocks that contain them predate humanity by unimaginable spans of time. Ice cores extracted from Greenland reveal radioactive isotopes that do not occur naturally anywhere on Earth. These elements are created only under tightly controlled nuclear conditions requiring advanced reactors or weapons. Their presence in ancient ice implies technological capabilities beyond even our current level. The isotopes appear in discrete layers separated by thousands of years, suggesting repeated cycles of nuclear advancement followed by complete disappearance. The pattern mirrors a chilling possibility: civilizations that reach nuclear mastery and then collapsed or erase themselves. Pacific Ocean sediment cores contain traces of plutonium embedded in layers corresponding to mass extinction events. Plutonium does not exist naturally. Its presence suggests that nuclear detonations may have contributed to some of Earth's greatest biological catastrophes. The quantities involved are extraordinary. Some formations contain concentrations that would require thousands of nuclear detonations. Even more disturbing, these layers include exotic elements produced only in particle accelerators, technology humanity has only recently developed. These nuclear signatures align perfectly with other anomalies: sudden climate shifts, mass extinctions, and the appearance of synthetic materials. Together, they suggest repeated episodes of advanced civilization, each leaving behind radioactive scars before vanishing entirely. And nuclear evidence is only part of the story. Any technological society must consume immense energy. That consumption inevitably reshapes atmospheric chemistry, leaving long-lasting signatures preserved in ice and sediment. Human activity has raised carbon dioxide levels by over 40% in just 2 centuries. That spike will remain visible in Earth's climate record millions of years from now. It is a permanent marker of industrial civilization. But ice cores from Antarctica tell us we were not the first. Within 800,000 years of atmospheric data, scientists have identified multiple rapid greenhouse gas surges identical to those caused by modern industry. These spikes follow the same pattern: sudden increases in carbon dioxide and methane, sustained for thousands of years, then abrupt decline. The timing and scale are too consistent to be random climate variation. Each episode suggests coordinated, planet-wide energy use rivaling or exceeding today's industrial output. And each ends, either through collapse or technological transition. Ocean sediments reveal even more extreme intervention. Chemical markers indicate large-scale atmospheric engineering, including aerosol deployment designed to regulate global temperature and rainfall. Such interventions require deep understanding of climate systems, knowledge humanity has only begun to acquire. The scale implies civilizations capable of treating Earth's atmosphere as an adjustable system. Greenland ice cores extending back millions of years contain synthetic gases that do not exist naturally, yet are extraordinarily effective greenhouse agents. Their ratios indicate deliberate design, not accidental release. Their molecular structures show optimization for specific atmospheric effects. Whoever created them understood climate physics in remarkable detail. North American soil layers from the same periods reveal altered precipitation and temperature patterns that align precisely with these atmospheric changes. The modifications were effective, maintaining stability despite conditions that should have triggered severe climate disruption. The implication is astonishing. These civilizations may have managed Earth's climate better than we do today, maintaining equilibrium through natural cycles that would otherwise cause disaster. But some evidence points to something even more ambitious. Earth's atmosphere preserves a complete record of planetary history, asteroid impacts, volcanic eruptions, the rise of oxygen, and the evolution of life. The resolution is so precise that individual eruptions can be identified thousands of years later. If civilizations reshape the atmosphere, the record would show it. And it does. Air bubbles trapped in amber contain samples from 100 million years ago. These show oxygen levels far higher than today, but with isotope patterns indicating artificial enrichment. The oxygen increase required extracting massive amounts of carbon dioxide while boosting oxygen production beyond biological limits. This represents planetary-scale engineering beyond anything humanity has attempted. Ice cores from both poles reveal repeated episodes of complete atmospheric restructuring, not just greenhouse gases, but nitrogen itself. Manipulating nitrogen at this scale would require processing the entire atmosphere. The resulting compositions appear optimized for industry, improving combustion, reducing corrosion, and enhancing materials processing. The air itself was engineered. Ocean sediments preserve traces of synthetic atmospheric gases unknown anywhere else in the solar system. These compounds serve multiple functions: thermal regulation, radiation shielding, and climate stabilization. Some layers show failed experiments, rapid changes followed by reversion, suggesting trial and error even among advanced societies. Most astonishing of all are atmospheric samples from 200 million years ago containing gases optimized for life forms that no longer exist. These compositions would be lethal to modern organisms, but ideal for entirely different biochemistry. This suggests Earth may have hosted multiple engineered biospheres, each shaped by its dominant civilization. And atmospheric engineering is only one chapter. The planet's history has been defined by 5 great mass extinctions. Scientists usually explain mass extinctions as a result of asteroid impacts, supervolcanoes, climate collapse, or other natural catastrophes. But when extinction events are examined closely, troubling irregularities emerge, patterns that don't behave like purely natural disasters. Take the Permian-Triassic extinction 252 million years ago. It erased nearly all marine life and the majority of land vertebrates. No other event came closer to completely resetting complex life on Earth. Yet the way life disappeared defies expectation. The losses were not random. Species sharing similar environments often had radically different survival outcomes. Organisms believed to be resilient vanished entirely, while others that should have been fragile passed through almost unchanged. This kind of selectivity is difficult to reconcile with volcanoes, impacts, or climate stress alone. Natural disasters act broadly. They punish exposure and tolerance. The Great Dying followed a different logic, one that appears discriminatory, as if certain biological systems were targeted while others were spared. Geochemical evidence from this boundary layer deepens a mystery. Sediments contain compounds that resemble synthetic biological toxins, substances highly effective at disrupting specific cellular processes while leaving others untouched. These chemicals do not occur naturally and appear globally distributed in precise proportions. Such coordination across land and ocean cannot be explained by atmospheric circulation or volcanic dispersal. The pattern resembles intentional deployment. Even more disturbing, ocean sediments from the same interval contain microscopic remnants consistent with engineered microorganisms. Their structure suggests artificial design rather than natural evolution. If correct, it implies the release of biological agents on a planetary scale. The Ordovician extinction, 445 million years ago, shows eerily similar features. Marine life collapsed selectively, and ecological niches were rapidly refilled by new organisms that appeared almost immediately in the fossil record, already adapted, already optimized. The transition was too fast. Evolution cannot generate fully functional ecosystems in such a short geological window. The sequence suggests replacement rather than recovery. Other extinction layers reveal additional anomalies. Radioactive isotope spikes appear precisely at extinction peaks, patterns consistent with large-scale nuclear activity. The intensity exceeds anything humanity has ever produced. Some layers even contain particles formed only by extreme energy reactions in the upper atmosphere, hinting at weapons deployed from orbit rather than Earth's surface. At the boundary marking the end of the dinosaurs, the asteroid impact is undeniable. But isotope irregularities within the crater suggest the object's trajectory may have been altered deliberately. The chemical signatures resemble those produced by nuclear propulsion systems. If true, some extinction events may not have been accidents of nature, but acts of planetary engineering. Each catastrophe erased dominant life forms and cleared the biosphere for new ones. Again and again, Earth was reshaped, and the deepest evidence lies frozen beneath Antarctica. 2 miles of ice preserve an uninterrupted planetary archive stretching back millions of years. Deep drilling has begun to reveal atmospheric compositions that conflict sharply with established history. Gas trapped at extreme depths shows signs of intense industrial activity during periods when Antarctica should have been forested and temperate. The chemistry indicates large-scale energy use and manufacturing at a time when no civilization is supposed to have existed. Radar surveys of the bedrock beneath the ice have identified geometric formations extending hundreds of miles, too symmetrical to be geological. Their electromagnetic properties indicate synthetic materials engineered to withstand extreme stress. Drilling beneath the ice has recovered organic remains bearing unmistakable signs of genetic modification. Artificial DNA sequences appear optimized for industrial use, radiation resistance, and survival in extreme environments. Mineral deposits beneath the ice show evidence of systematic extraction. Rare elements appear concentrated in patterns matching industrial mining rather than natural deposition. Even more astonishing are microscopic machine components recovered from subglacial sediments. Their construction suggests nanotechnology far beyond current human capability. Some buried structures appear designed for space operations, launch facilities positioned for polar orbits. Power networks span the continent, drawing energy from geothermal systems on a scale far exceeding modern output. Chemical evidence suggests Antarctica's ice sheet may itself be engineered, created rapidly, not gradually. A controlled planetary freeze may have been used to preserve evidence or conceal infrastructure. Antarctica is not alone. Using methods originally developed to search for alien civilizations, scientists are now identifying techno-signatures within Earth's own geological record. Industrial pollution patterns, artificial isotopes, and mega-engineering traces appear repeatedly across deep time. Every technique used to detect extraterrestrial intelligence has yielded positive results. Here, at home, spectral analysis reveals pollution identical to advanced industry. Radar surveys identify continent-spanning infrastructure. Drilling recovers manufactured artifacts millions of years too old. Satellite imaging reveals planetary-scale geometric patterns invisible from the ground, project designed by civilizations that thought globally. Some civilizations appear to have mastered climate and ocean engineering. Others focus on space expansion. Still others reshape biology itself. The implications extend far beyond Earth. Intelligence may arise repeatedly on habitable worlds, leaving behind civilizations that vanish long before observers arrive. Humanity may not be discovering the universe's first intelligence, but its most recent one. Genetic evidence reinforces this conclusion. Ancient DNA preserved in permafrost and amber contains artificial sequences, patterns impossible through natural evolution. Identical modifications appear across unrelated species and continents. These changes enhance intelligence, resilience, longevity, traits useful to technological societies. Some organisms contain biological data storage systems, genetic structures encoding mathematical constants, star maps, and technical instructions. Others show dormant genes that can still be activated, revealing traits with no evolutionary purpose today. Mineral formations add another layer of mystery. Certain crystal lattices encode information, respond to electromagnetic fields, and exhibit computational behavior. These structures appear to process data using geology itself. Networks of these crystals extend for miles underground, powered by geothermal and radioactive energy, operating for millions of years without maintenance. Some formations appear to store entire archives, knowledge preserved beyond civilization's collapse. Seismic and electromagnetic correlations suggest these systems may still be active, subtly influencing tectonics and climate to maintain planetary stability. Beyond Earth, orbital surveys reveal ancient artificial objects in stable gravitational positions. Materials unknown to modern science form structures designed to last millions of years. Mining scars appear on asteroids. Facilities exist in distant solar orbits. Signals continue to transmit, monitoring Earth long after their creators vanished. The deep ocean preserves even more. Sonar mapping reveals vast underwater structures, transportation networks, and industrial installations built to survive crushing pressure. Artifacts recovered from the abyss show advanced manufacturing and energy systems harvesting geothermal power. Entire underwater cities may have existed, protected from surface catastrophes while supporting planetary-scale projects. Evidence extends to the Moon, Mars, the asteroid belt, and beyond. Terraforming attempts, interplanetary logistics, solar system-wide infrastructure. And finally, there are the messages, information encoded in crystals, isotopes, atmospheric chemistry, and sediment patterns, designed to be discovered by future civilizations. Warnings, instructions, invitations. Some messages activate only when technological thresholds are reached, suggesting guided development across deep time. The pattern is clear. Civilizations rise, advance rapidly, then collapse every 10 to 50,000 years. The causes repeat: environmental destruction, resource exhaustion, uncontrolled power. We are following the same path. But for the first time, a civilization can see the full record. We can choose whether to repeat the cycle or become the first to break it. The hypothesis leaves us with one final realization. We are not the first intelligence on Earth, and we may not be alone, even now. The recovered records appear to follow humanity's technological trajectory, measuring our progress and estimating whether long-term sustainability is achievable. Some of these systems are not merely passive archives. Evidence suggests they are capable of receiving feedback, implying that oversight may still be active. This raises a possibility that remnants of earlier civilizations continue operating from concealed locations on Earth or from installations beyond the planet. These monitoring systems show signs of continuous refinement. Each phase of guidance appears more precise than the last, shaped by the accumulated failures and partial successes of civilizations that came before us. The pattern suggests a learning intelligence, one that adjusts its approach with every new society that emerges. Recent findings indicate that these systems may be approaching a point of limited engagement. Signals and activation patterns imply preparation for direct interaction as humanity nears technological thresholds that previously led other civilizations to collapse. The contact frameworks appear intentionally restrained, offering support without removing autonomy, allowing societies to solve problems rather than be rescued from them. This possibility forces an uncomfortable question. If guidance exists, how much of human progress has truly been independent? Our development may have unfolded within invisible boundaries shaped by predecessors who are determined that we not repeat their mistakes. Yet the ultimate measure of our readiness may be whether we can sustain advanced technology without relying on unseen intervention. Even more unsettling is the realization that the most advanced technologies of past civilizations may surround us unnoticed. These systems appear so deeply integrated with natural processes that they no longer register as artificial. They operate at levels where technology and physics become indistinguishable. Modern physics has revealed that certain physical constants are tuned with extraordinary precision. The degree of fine adjustment seems excessive for random cosmic outcomes. These values optimize chemistry, energy flow, and biological complexity on planetary scales. Even more striking, some constants appear to shift subtly over geological time, aligning with major evolutionary transitions. These variations are not chaotic. They follow patterns that introduce selective pressures, encouraging complexity while preventing environmental collapse. The balance is precise enough to suggest intentional calibration rather than coincidence. Further analysis of quantum fluctuations reveals structured patterns embedded within space-time itself. These patterns resemble computational architectures operating through quantum fields rather than machines. The scale is planetary. The duration spans billions of years. Such systems would represent technology that no longer relies on hardware. Instead, they function through fundamental forces, processing information and influencing matter through the architecture of reality itself. Gravitational anomalies detected by high-precision instruments reveal invisible mass distributions affecting Earth's geology and atmosphere. These structures exert controlled influence through gravity and electromagnetism, stabilizing tectonic systems, regulating volcanism, and reducing the probability of catastrophic impacts. Asteroid deflection, atmospheric balance, even magnetic field stabilization appear achievable through these field-based technologies. No moving parts. No visible intervention. Only subtle corrections woven into natural forces. Biology also shows signs of direction. Evolutionary pathways display improbable timing and coordination. Traits associated with intelligence, cooperation, and tool use appear repeatedly favored, while evolutionary dead ends are quietly avoided. Genetic analysis indicates that key transitions occurred with precision inconsistent with blind mutation alone. The coordination suggests influence applied across deep time, ensuring that intelligence would eventually arise. Earth's climate system shows stability exceeding what natural feedback loops should allow. Atmospheric and oceanic parameters remain within narrow bounds despite destabilizing forces. The balance appears actively maintained. Recent experiments hint that these regulatory systems may soon become detectable. As human science approaches the threshold required to recognize such operations, the veil appears to be lifting, slowly, deliberately. These hidden systems may represent the highest achievement of previous civilizations, technologies that function through reality itself. They may be the reason Earth has repeatedly supported advanced life despite cosmic conditions that should have prevented it. Understanding these systems may be essential for humanity's survival. They offer immense potential, but also responsibility. Mastery would require wisdom equal to power. Beyond Earth, evidence suggests that contingency systems were established throughout the solar system. Monitoring stations occupy optimal gravitational positions, tracking hazardous objects long before impact trajectories form. Some asteroid paths show unmistakable signs of adjustment, altered just enough to prevent collision while preserving orbital stability. Solar monitoring platforms appear positioned to counter extreme solar events. Magnetic reinforcement systems may have stabilized Earth's field during geomagnetic reversals, preserving atmospheric integrity when natural protection weakened. Orbital debris appears to be actively managed, removed without detectable residue. Even more remarkable, these systems may not be isolated. Patterns suggest coordination with similar networks around distant stars, forming a distributed defense infrastructure protecting developing civilizations across the galaxy. These networks adapt, they learn, they respond to new threats, and recent data suggests they may soon acknowledge humanity's awareness of their existence. The implication is profound. Protection has limits. Responsibility may soon transfer. Humanity may be nearing the stage where we must maintain these systems ourselves, where protected development ends and stewardship begins. Parallel to this revelation is the emergence of quantum archaeology. This new discipline extracts information not from artifacts, but from quantum traces embedded in matter itself. Events long erased from physical evidence remain encoded in quantum fields. Entanglement preserves history. With the right tools, information can be read from minerals, crystals, even empty space. Using these techniques, scientists have reconstructed industrial processes millions of years old. Some findings reveal planetary-scale quantum computation, using Earth's magnetic and electrical systems as processing substrates. These ancient quantum systems operated with capacities beyond anything imaginable today, solving problems that would require the computational equivalent of the entire planet. Space-time itself appears to function as an archive, preserving records of every major technological event. This archive is not passive. It is maintained, refreshed to prevent decay. Quantum communication networks span the solar system, enabling instantaneous exchange across vast distances. They have operated continuously for millions of years without degradation. Recovered quantum data includes detailed designs of technologies far beyond modern engineering, energy systems, materials, propulsion. Some information appears intentionally stored for future civilizations to access. These discoveries suggest that preserving knowledge, not structures, was the ultimate priority of advanced societies. The most extraordinary finding, however, involves consciousness itself. Evidence suggests that previous civilizations developed methods to preserve conscious patterns beyond biological death. Neural interface technologies appear capable of transferring minds into durable storage systems. Crystalline structures have been found containing thousands of preserved consciousness patterns, stable, intact, and potentially active after millions of years. These systems may still be operational. Some show signs of internal activity. Communication protocols exist. Preserved minds appear to have formed virtual societies, continuing scientific and philosophical development long after their physical civilizations vanished. Some systems are designed for eventual reintegration into biological or synthetic forms, implying planned resurrection through successive civilizations. Human research into consciousness now parallels these ancient methods. We may be approaching compatibility. Beyond Earth, evidence points to a galactic civilization network. Structures around distant stars mirror engineering signatures found on Earth. Communication patterns suggest coordination across thousands of worlds. Earth may have served as a regional hub, a node in a vast interstellar system. Biological evidence indicates that life on Earth has been modified to support off-world environments, suggesting participation in galactic bioengineering efforts. As humanity approaches technological maturity, activation patterns imply an invitation phase may be nearing. Entry conditions appear strict: sustainability, restraint, and responsibility. The deep time record shows what happens when societies fail these tests. Humanity is accelerating along a familiar path. Artificial intelligence, genetic engineering, and energy manipulation echo trajectories that previously ended in collapse. But there's a difference. We can see the pattern. We have the record. We have the warnings and the solutions. The systems left behind were not meant to save us. They were meant to teach us. We stand at a decision point measured not in centuries, but decades. What we choose will determine whether we join the lineage of civilizations that transcend extinction or become another layer in the geological archive. The universe has preserved the lesson. Now it is waiting for the answer.